and yes, and brain geometry.
I think you should make your voice louder so those at the back can hear you. Okay.
No, go there, go there. You have that space.
This represents a cuboid, and it has 6 surfaces and 12 edges. And we have the formula for calculating the area of this cuboid is 2 multiplied by b times h plus 2 multiplied by l times h plus 2 multiplied by l times b. So if I have my rule here, I can measure the length, the height, and the breadth, so that I'll fix them into the formula. Then I'll get my area of the keyboard. In the keyboard too, we also have this cylinder. Yeah, we are representing this. We are representing this as a cylinder. And the cylinder half of a circle and half of a circle, or from the point to any of the circumference. When you extend a line from a point to any of the circumference, that line is called the radius. So they can tell you to calculate for the radius of this what? Of this cylinder. As long as they can tell you to calculate the area of this what? Cylinder. And we have the formula for calculating the area of this cylinder, which is pi r squared h. So when we open this cylinder, we are assuming when we open, we have a circle at the base and at the top 2 over there. So when we divide the circle into 2, we have the diameter and we have the height 2 over there. So when you calculate for them, then you fix them into the formula, then you get your area of this cylinder. So I will allow my brother to come and also come in and do his presentation.
You are going to repeat it.
When this cylinder is fixed into this hole like this. This over here. You see? So you can this is a square, a plane shape, which has all its sides equal. The length here is equal to here, and here, and here. We can find the area of this square to be L square, which is this and this, which is L square. You can also move further to find the perimeter of this square, which is this length plus this plus this plus this, which is 4L, which L stands for the length. When we come to this cuboid here, when we pick this in, we have these gates here, and we have
Now remove the mat. Remove it. Hey, put your phone. Go on, go on.
when we open this gate, we'll be having an angle of 90 degrees here. When we turn to this side, we have the circle theory, which is the theory 3, which says that
Let me see it. Okay. So you can show it to them, but make sure always you show it to us here.
which says that the diameter of a circle, the diameter of a circle in a circumference is 90 degrees, or the angle subtended by a diameter at the circumference of the circle is 90 degrees. When we turn to the other side, we have the circle theory, which is theory 2 over here. The angle subtended at the center of the circle, which says that the angle which an arc of a circle subtended at the center of the circle is twice, that is that is subtended at any point of the ring.
To conclude, we also have this right angle triangle over here. And we are using this right angle triangle to show you the Pythagoras theorem. We have a theta here. Theta. So this theta is facing this side. So where the theta faces is the what? Opposite. And the longer side here represents the what? The hypotenuse. So say any place in case the hypotenuse is being placed over here, where its faces become the opposite. So where the hypotenuse faces become the opposite. So here down here become the what? The adjacent. So, and this one is in circle theory. Property 4, property 2. So say here the half of the small angle here, angle AC, half of angle AC is equal to ABC. So it's equal to ABC. Then
Okay, clap for them. It's okay. Put it on. If I ask you a question, then you put it down. Okay. You have done yours. We also have our questions. How did you come about with it? Did you copy from somewhere, or you sat down to do it on your own?
so we sat down and planned, and then we go about it.
So you didn't copy from any place?
No sir.
You did it yourself?
Yes sir.
Okay. Now, you have shown us a lot of things where I don't know it's. So, Aksimi, I see. Show me the point where you have the right angle triangle. Raise it up. Okay. I see theta there. And what they said was that anytime you see theta, the side that is opposite the theta, or that side that is facing the theta, is the opposite. And I think that is commendable. Clap for them. But I have a problem with the Asasco theorem, because there is nothing telling me that twice the angle, or the angle subtended at the circumference by a chord added to the angle subtended at the other side is equal to 180. What? I'm not convinced. So convince me. I'm not convinced. I've seen this one here. Angle subtended at the circumference by a chord will give us what? A supplementary 180. Yes, but I am not seeing anything that is telling me it is supplementary. Or in any case, maybe they should have explained it better for me to understand. What can you say? I hope you're listening. But if there is a chord is representing what? A straight line.
Yes.
Isn't it?
Yes, it is.
And angles on a straight line is what?
180.
So, if a chord subtends two angles at the opposite ends, it means the sum is equal to the sum of angles on a straight line. That is what you should have told us. But it didn't come. So, whenever you see a chord, what should come in your mind is what? 180. Angle subtended, when you add, is 180. I hope you have learned something here. Show it to them. Show it to them. So this is what I'm saying. Show them the chord. Use your hand to show them the chord. Show them the chord. Now, a chord is a straight line. Can you all see? Yes. We have an angle at the top of the chord and another angle down. Since the sum of angles on the straight line is 180 and we knew in class 4, it means the two angles, one top and down, when you add, it gives you the sum of angle on a straight line. That is the interpretation or explanation. So anytime when you propose to be out, you know, sir, if A is up there and then down is 56, it means A plus 56 is equal to the sum of angles on the chord, and it is what? 180. So you can remember and then you solve your note. Right. Good. I think you have done something. And my noble men are awarding the marks.
I have something.
Okay, you can come in.
I think they've done well. My only problem is the part they brought in the circle theory. If they have left that part out of whatever they are doing, it would have been perfect. Because the circle theory deals with the angles. And there is nothing there that proves that I can prove any of the theory we want to talk about. I don't know if you get my point. Nothing there shows that, oh, so Akolabi who we are, Obetimatia say angle way, twice, and an angle way is supplementary. There's nothing in that shows. Apart from that, I think if you have left that part out of it, it should have been nice.
I even think that still they could have still maintained it, but explaining, trying to say, oh, when you have four lines, one it in about trim. Into a sort angle, any firm angle, the boma, you get 180. So anytime student you are solving a question, now when you are supposed to be another Kaiser, where a line will give you it gives you something, and that one would have been okay. Let's see. All the things you have presented here, raise it up. My camera is capturing.
It's true.
What is the mathematical application of that? It's like they didn't expect a move heading. And then yes, we are listening.
So when it comes to the mathematical,
Remove it and talk, and the rest who are not with it should have it on. We want to listen to the one who is talking.
Please don't be touching the
Front don't know that.
so when it comes to the mathematical application, like for example the Pythagoras theorem. When a ladder leans on a wall, it forms a right angle.
You did not get my question. Adekudina ukurano. Mathematical model ben yebetimi di aye. We want the application. Sir, something that what they have created can do. Because they say, well, I know something like abstract, something which people can learn from. But the application,
Like in terms of everyday life.
Everyday life.
Like
what when
you were talking about the keyboard, you made mention of like the volume or the area. I think I said volume, not the area. So like, what is the formula? Like, how can we use the formula in our everyday life? That length and breadth and height. I get number.
Okay, clap for them and then they say that. And then you cry. Science B.
Because of first
So this one is the previous group.
Give them the bell. Their time starts. 10 minutes.
Okay, so this is
Remove the mask and talk.
10 minutes.
our wonderful device here is used to calculate, is used to solve any Pythagoras theorem question. You know that
You didn't present your names. Your names, and then presentation. The class you represent. It's normal for you to do that.
My name is Asari Beneza.
My name is Dokubatu.
My name is Mario Fosu.
Okay, so we are here on 3 science B, and this is our experiment. So this is a practical application of the Pythagoras theorem. So this device, this instrument here, is used to calculate for any question under Pythagoras theorem. So this right here is our hypotenuse. This here is the opposite, and then here is the adjacent. And then we know that we can. Okay, so let's label this.
Come again with your. Come again. Yes, come again. You were showing us the sides. Yes, come again.
This here is the hypotenuse. Here is the adjacent, and then here is the opposite.
Where is the adjacent?
This one, the length.
No, I can see. You turn it to them. I can see.
Yes. And here,
But you showed me hypotenuse and showed me adjacent somewhere.
yes, this one. This is the adjacent.
Show me again.
Here is the hypotenuse.
Yes. No, I can see.
So you can't get the setting.
You can. Okay. Good.
So this is the hypotenuse. This one. Here is the opposite.
Put the hypotenuse to the highest point. Put it to the highest point. I didn't ask you to remove. Okay, now go on. Now show me the sides again. No last shot. Show me the size again.
Here is the hypotenuse. Here is the opposite. And then here is the adjacent. So let's represent the hypotenuse with the letter A. And then here the letter B and here C. So we all know that we are about to prove that formula. A square is equal to B square plus C square. To find the length of this one is the square root of the sum of the square of the length of the opposite and then the square of the length of the adjacent. So let's pick numbers randomly. So if we have the adjacent of 4 centimeters, we move 4 centimeters for the adjacent. So here's our 0 mark. So from the 0 mark, okay, so with our view here, we don't need to adjust it. We have a period. So by pulling this, you see it moving itself.
Just.
Yes. Pull it a little. So now we have our mark on the 4 centimeter at the adjacent. And then for the opposite here, let's say we want 3 centimeters. So we reduce here, giving us 3 centimeters. So provided we've been given only the length of the opposite and the adjacent, we are supposed to find the hypotenuse. First of all, let's record our value here for the hypotenuse. It has already given us the answer. So we'll prove it for you. So our answer here is
Pause. How many brothers are here? Hands up. 1, 2, 3, 4, 5. About 6. About 6. Okay.
so we provided the length of the opposite and then the adjacent. So our opposite is 3 centimeters and our adjacent is 4 centimeters. Can you come on up? Yes, sir. Come. The reading here of the hypotenuse is what? How many centimeters? The mark is on what? 5, right? Yes. 5 centimeters. So let's point it on our calculator. We are saying that the sum of the square of these two lengths will give us what? This. So the here is 4. So 4 square plus 3 square is equal to 25. So the square root of the 25 here is equal to the 5, which you've already obtained here. Did you all get it? Let's try another example. Provided we've been given adjacent of 5 centimeters. So we adjust our root to 5 centimeters. So now we have our 5 centimeters as the adjacent. And then let's say the opposite of 4 centimeters. So remove this one. So I have 4 centimeters. So calculating for the hypotenuse is the same addition of the square of this length. So we have here to be 5 and here to be 4. I get 6.40. And then if someone will come and see if I mention, you might think that I've already calculated. So you come. Here is what? 6. And then if you could count the number of the lines there, you could see it's on the 4th one, 6.4. So with our device here, when you just regulate the values of the adjacent and the opposite, you just regulate values of the two sides, automatically you get the third length. Did you understand? Thank you very much.
Okay. Now raise the project up and turn it to our view. Okay. Turn it back to them. In your presentation, you said back the hypotenuse. Touch it for me. Good. You showed us the hypotenuse. Then straight away you went to the adjacent without giving me the angle. But you know or you agree that it is the angle that determines the adjacent. So why did you have to jump from hypotenuse to adjacent without making me know the angle? Answer to their hearing.
I think unintentionally skipped that part.
So where is your angle? So you skipped it. Where is your angle?
The angle here 90 degrees. Provided the angle between opposite and adjacent is 90 degrees.
Where is your angle?
Between
No.
No, I'm not copying his claim. Copying is that
I know, but I don't have to answer them. Now, hey, all of you, look at something. Onuna wire that you. Bring it closer to me. Bring it closer. Now, if you look at your project or presentation, you see that there is something here which looks like creating a mark or an angle there, but they have forgotten to see themselves. Yes. You've forgotten to see. So with your presentation, silence here. I remember the video is capturing. I remember you said this is adjacent. Or
no, you said the down part is adjacent.
the down part is adjacent. Okay, then with what they have is correct. This is the angle determining the opposite and the adjacent. So, of course, if this is the angle, then this becomes the opposite, and that becomes the adjacent. Any question?
I want to find out what can be the title for this particular project.
we are proving the Pythagoras theorem. That formula a squared plus b squared. A squared is equal to b squared plus c squared.
Hello. I hold a little beef for them. The beef I hold for them is that trade has not been taught in class. So if trade is in trade, that we normally tell the students that where the angle is determines which part to be the opposite and which part to be the adjacent. Not that, that's notwithstanding. I still want to say that since they wanted to do that, they still had a chance to do some research based on Pythagoras theorem to know that part. Okay, that's why I hold a little bit for you because that concept has not really been taught yet. But when it comes to the angles, then it is the angle that determines which part becomes opposite and which part becomes the adjacent.
You are not done.
They are not done. Honestly speaking, when they told me they want to do this, I challenged them. I said it will be a little complex but it would be nice if they can do it. And they've challenged me to do it.
If there is no silence, we cannot continue. I'm not done with my question. Oh, wait. If you see me seated here, you think I teach physics in Guam?
What is physics without maths?
What is physics without maths? Tell me the application of what you have done. What can this be used for? That aspect of it, because that is where the 20 and 30 marks are.
How many are so 24 plus 42. Then the other side, how many people are there? 40 plus 40.
I was at Madam, the only one of them more than 6 or 7 goals I will show them to live it. But we don't say they will manage with it. Because but this one is even more than so you say
Okay, now the question is answer the question.
Okay, so what you've done, which is the proving a Pythagoras theorem formula. This can be used. The application of this is finding, even in vectors, is inside to find the length of a side or to the length between 2 points, provided you have 3 points, and then the first one and the second one, and there's an angle provided. So this is used to find the length between 2 points.
you have not convinced any of us. We don't understand. Now listen. We are giving you one more chance again. What is the application of what you have presented in our daily normal lives?
You can see where the angle was on this.
Okay.
And when the
It's going to be against the right. You understand? We are listening.
I want to create a scenario. Let's say this is a wall. This is a wall. Wait. Let's say here is a wall. There is a wall. So the distance between the bottom of the wall to any point of the wall. And then let's say there's a ladder here. So this is our ladder. And then we have the length of the ladder. So when you put the ladder on the ground and then you slant it onto the wall like this, you can determine the length or the distance between the foot of the ladder to the end of the wall. The same way, if you only have the length of the wall like this and then the distance between the foot of the ladder and then the point at which the wall starts, you can determine the length of the ladder here.
So if that person is doing that, what is he doing?
He's
We're
finding.
talking about walls, we're talking about ladders. Where in real life applications can you see that?
Finding distance, like I don't know.
Somebody has said the answer. Jumping construction, it is used in architecture. That's what he's asking you. That where can you apply this in our daily life?
I think your teacher is helping you out here. Clap for them, let them sit down. Clap for them, let them sit down.
Hello. Hello. The main idea behind this is not who me. The main idea is for our students to know the importance of mathematics. So some of the things we try to chip in one or two, so that you know that whatever you are doing is important.
We are considering the right type.
The next one after the
How relevant to give the 35. Because you're depending on right up now. And when you now, and the application you can do it.
How do you need to come out with the application?
the concept
They need to
they can read 2 minutes and how to do it. So they are using this which is school. And moving becomes the same thing. Pythagoras theorem is
Science 8. Clap for them as they come. There is too much noise. We have to finish. You go and take your lunch, then you begin the quiz. So let's finish successfully.
Honorable Chairman, panel of judge, AGRIC timekeepers, I, as a Hamford and my colleagues here, are here to present what during science 8 students on 2 square problem and also visualize math square machine. And I would like my colleagues to introduce themselves to you.
I'm called Yankee. We start with this. We can all see that it's a square, right? And we know that a square has equal sides. So you represent this side by A, and definitely this side, and that side will be A. Is it right?
Pause there. Your nose mask on. Now yours can be off as we talk.
Okay.
Yeah, go on.
We are going to get a small square out of this, out of the big square. So we will label the side of the small square B. We all know that this side is A. This side is A. But as soon as we cut another square off, this side becomes A plus B. A minus B. Sorry. Now, we are going to take this off. If you take it off, now we have A minus B here. Initially, it was a square. We are presenting on the difference of 2 squares. So, a square, then a rectangle. Then the area of a rectangle includes the difference of 2 squares. We are going to take this part also off. Then we will insert it here. We have a rectangle. Now, this side, we all know it's A minus B. But this side becomes A plus B because this is A and this small one is B. So A plus B, then A minus B. We all know the formula for calculating the area of the rectangle. That's length times breadth. So the length A minus B times the length A plus B times the breadth A minus B will give us A square minus B square. That's the difference of two squares. Okay. We are going on to explain this wonderful machine here. Now, as you can see, this one, ordinary class 1 kindergarten student can even understand this one. We are going to rotate it. We know that this square is 9. Now, what is 4 square?
When you rotate it, 4 square is equal to 16. And we all know that 4 square is equal to 16. And this one doesn't involve you using calculator. You can see it through the holes and it's visual because you are able to see it through it without using calculator. And you all know
Let us see. We are not seeing.
We all know that 4 square is equal to 16. And 5 square is also equal to 25. 5 square is 25. This one we are not using calculator. And when we move it again, we know 7 square is equal to 49. 7 square is 49. So this one it helps us to solve even those who can't use calculator, who are not getting access to calculator. They can have this in their own comfortable home and they will practice it. Whilst you are rotating it and solving your work, you will be able to solve it without using calculator.
For me, your second presentation,
Keep quiet and listen.
I don't see any mathematical formula being used anywhere. But you see, at least you have tried to be creative with your thinking by trying to use your mind to create something. It's quite possible. But I don't really see the mathematical formula being used in your creativity. So if maybe you have any mathematical formula that you applied in your creativity, I would like to know. Yeah.
As we trade these two as different of 2 squares, and this one it shows you that a square root of something is equal to something.
Very well.
And
Hey, let's listen to the square.
you will be having a question like difference of 2 square, and they will give you 7 square minus maybe 5 square. Because maybe you are not getting access to calculator, but this one is there for you. You will just rotate it so that you will see that 7 square is equal to 49 and 5 square is equal to 25. So it looks like it's a complement to this one.
presentation.
Yes.
What is the application?
When we have a square there, and as for square, you measure it. Or rectangle, you measure the length and the breadth. So, how do you know that you have to measure the length and the breadth of something? And you're going to say, let me say, a table like this one. You will need measurements, and this one will help you because when you know that a square, because this is 2, this one and this side, you will combine it together. Because this if this side is A, this side 2 is A, and this side is B, this side 2 is B.
Application. You are talking about AB. Application. Allow them to tell us the application and let's go.
So you can use it to measure the length and the breadth of the page.
Wait. How?
What about saying that you can use this idea to determine the area of a table by using like the A times B, like that your expression. I get what I'm saying. You can use this idea to determine what the area of this table surface. That can be used here, so that could be the application. I get what I'm saying. So
Okay, so you agree, but you've not been able to convince us. You've not told us anything applicable about it. Last chance. Yes, talk about it.
This can be used constructors can use this for construction of roads and buildings.
How? Allow them to talk.
Let's say a surveyor is coming to measure a land. The person will use the length and breadth to measure the size of the land.
the area,
The area of the land.
Uh-huh.
So it can be used by constructors and surveyors in measurement of the land.
Wait. According to her, it can be used by surveyors to measure the area of land. How? Allow it.
Maybe I am going to write and the surveyor comes. He or she will know that length times breadth is the area of that particular land. So knowing that this is the breadth and this is the length, he will be able to measure the land accurately.
Provided that that surveyor knows the length of the land, you can use the formula A squared minus B squared to find the area of that particular land.
Is it A squared plus B squared?
Let us say the length of the land, the length of the land is 5 centimeters.
Now your second one. You have exhausted the first one.
Yes.
Your second one.
Please, and this one to help the surveyors to know the number of floors that they are going to sell to someone. Let me say the agent, the company to meet the land. So then when they measure the area of the land and they know that 1 acre is equal to this, it will help them to determine that the next acre will also be equal to this. So it will be the same area.
Because actually, it's wrong here. We are talking about this place. But this is the wrong.
Yeah. So that's where we are not trying to get it. Okay. If you don't keep quiet, let's finish this. We will not be done. The second presentation. What is the mathematical brain behind it? And its application in real daily lives. Allow them to talk.
The mathematical brain behind this application, this setup, is that when you have a little kid, your child is too small to the extent that your child is not able to use calculator. You will rotate this one to show it where that 7 square is equal to 49 without using calculator. And also, say, because we are all here as students, but not all of us have calculator. But maybe when you go to the house, in class, you get somebody's calculator, but when you go to the house, and you are in need of something like 7 square, because what, and you are not in need of, you are not getting the calculator, you can use this thing to rotate it so that it will help you to know that 7 square is equal to 49. The mathematical brain. It helps you to know the square number of something.
I know something. Let me say that you could have done better than what you did. You could have done better. You had avenue to have different things within a certain box which can be operated. Assuming you were to have a machine generated and then you've worked it out such that if you should put in a certain investment, assuming it is an investment box or something, machine, and so when you do that, it should generate something to you. This is so simple to do. There are other things you could have done using the binary operation, something. Okay, when you bring in this is how your money, you can even go to real life, something like what do you call snit, whatever. And then you say that, okay, so if your contributions are this, then it means you would gain this. So know how to. Then you explain that. But this is so simple. 7 and then 7 square is so simple.
Hold on. Yes, the idea is there. The point is, it's not for us here. It's so simple for secondary school. But when you are teaching squares, hold on. If you are teaching squares at the basic school and you are introducing them to squares, this becomes easy for you to do. So I was expecting them to say that this forms as a basis for the completion of squares.
For the basic people.
For the basic people. I was expecting them to say that. Other than that, it's okay. And yes.
And then something more challenging.
They could have added some more features to that machine.
Same machine.
That could have brought other things out. Don't worry. I also expect you to say that, sir, it's for a playing toy to generate interest in mathematics. If you said that, I have nothing against it. But you cannot really show, say, the concept is this. The reason is that because training features were not part of it. That's why you are struggling to explain that part. You see that we are not asking you much question about this one. Because this one is at our level and everybody is okay with it. You are struggling to explain this one. That's right.
Okay, clap for them as they sit down.
Hello. Now, these people are there, they are compiling them. But what I want to say is that I want you to laugh for yourself. Hey! All the 3 classes here are very well. I'm looking at something like if we are giving you like 1 or 2 weeks to prepare, then you could have come up with something more complicated. Don't say your thing there, we need it. Please bring it here, we need it. I need it. Bring the other one. The reason I'm trying to encourage you or appreciate your effort is that I've supervised like 6 or 7 classes already. I went to one of the class and instead of bringing something concrete, they went to buy biscuits, toffees, and they came to demonstrate how to do profit and loss as their science project. You see, now you see the thoughts that went into that. But looking at the ones I've looked at, yours, yes, you see that a lot of thoughts has gone into it. So we thank you for this effort. Just say, even though I agree that your product or whatever you came up with is more complicated than the other classes. There's one of the art class I went whose presentation was far better than all of you. The reason is they went back to the history behind the thing, who propounded the thing, how it came about, where it can be used in academics and real life. Now we have academics like computing of squares. Where do we use it? That is in academics. In real life, where do we use it? And you see that